want to talk about a roadmap. Not the kind that space agencies produce every decade or so, glossy, theoretical, full of exciting artist concepts and conveniently vague timelines. Those have their place. They get people's appetites up, and some genuinely useful work gets done riding that wave of inspiration. But inspiration without architecture stalls. We've seen that enough times to know it's true. What I'm proposing is different. 10 stages, sequential, each one built on the last, each one providing a support layer to every stage that comes after it. And the whole thing driven not by government committees, but by the oldest and most effective engine humanity has ever produced, commerce. Let's walk through it. Stage 1, Earth suborbital. This is the foundation. The on-ramp, suborbital flight, is where you prove out your vehicles, your life support, your crew systems, and your operational rhythms without the full commitment of achieving orbit. It's also, not coincidentally, where the early commercial market lives right now. Space tourism, research payloads, point-to-point cargo. The suborbital tier is already generating revenue, and revenue is what keeps the lights on while you build the next thing. Don't dismiss this layer. It's the base of the pyramid. Stage 2, low Earth orbit. LEO is where humanity learned to live in space. It's where we still live, aboard the International Space Station. But the ISS is a government project, and it won't be there forever. What comes next in LEO is commercial stations, commercial manufacturing, commercial research platforms. The infrastructure of LEO needs to be owned and operated by people with a profit motive, because that's the only model that sustains itself without a congressional appropriations fight every year. LEO has to become routine, boring even. That's how you know it's working. Stage 3, geosynchronous orbit, 22,000 miles up. This is where most of your telecommunications satellites live, and it's been commercially operated for decades, which means the business case is already proven. What hasn't been done is crewed operations and servicing at GEO. The infrastructure to support humans at that altitude, to service and upgrade the assets already there, to build and deploy larger structures. That's the next frontier at this stage, and it's a lucrative one. Stage 4, cislunar space, between the Earth and the Moon. This is where it starts to get interesting in a way that makes the hair on the back of your neck stand up a little. Cislunar space is vast. The Gateway concept, a crewed outpost in lunar orbit, is one piece of it, but cislunar space is also where you establish the logistics chain that makes everything beyond the Moon possible. Fuel depots, transit hubs, communication relays. The cislunar tier is the interstate highway system of deep space. Get this wrong, and everything past it suffers. Stage 5, translunar space, beyond the Moon, but not yet to Mars. This is the region where you find out how well your deep space systems actually perform over sustained duration. Long-duration crew operations, radiation management, autonomous systems that don't rely on quick communication with Earth. Translunar missions are where you stop pretending you've got deep space figured out and start finding out whether you actually do. It's also where resource prospecting begins in earnest. The asteroid belt isn't far in terms of trajectory, and what's out there is worth going after. Stage 6, Trans-Ares space, Mars, and beyond. I call it Trans-Ares, the space through and past the red planet. This is the stage most people are talking about when they talk about going to Mars. And yes, going to Mars matters enormously, but Mars is a waypoint, not a destination. The infrastructure you build to sustain humans on Mars, closed-loop life support, in-situ resource utilization, long-duration surface operations, is the same infrastructure you'll need further out. Mars is the shakedown cruise for the deeper solar system. Treat it like one. Stage 7, the outer solar system. Jupiter, Saturn, Uranus, Neptune, Pluto, and everything in between, including the asteroid belt, which deserves a conversation all its own. And let's start there. The asteroid belt is not empty space with a few rocks in it. It is a resource inventory of staggering scale, metals, silicates, water, ice, carbon compounds, sitting in orbits that, with the right propulsion, are accessible in ways the surface of Mars is not. A single metallic asteroid of modest size contains more iron and nickel than humanity has ever mined in its entire history. The commercial case for asteroid resource extraction isn't speculative anymore. It's an engineering and logistics problem, which is a very different thing. And this stage is where that industry matures. Beyond the belt, the gas giants and their moon systems represent the next great theater of human exploration. The moons of Jupiter alone, Io, Europa, Ganymede, Callisto, are worlds unto themselves, each with a different character and a different set of scientific and resource questions worth answering. Europa's subsurface ocean is arguably the most compelling target in the solar system for the search for life beyond Earth. Saturn's moon Titan has lakes of liquid methane and an atmosphere thicker than Earth's. These are not flyby destinations. These are places where humans will eventually set up operations, and the infrastructure work of every prior stage is what makes that possible. And then there's Pluto. Yes, Pluto. I know it was demoted. I don't particularly care, and neither should you, because what Pluto actually is a complex, geologically active world at the edge of the Kuiper Belt with a thin nitrogen atmosphere and mountain ranges of water ice is far more interesting than whatever classification the International Astronomical Union assigned to it. New Horizons gave us a tantalizing glimpse in 2015. What we need is boots on the ground, or at least a crewed vehicle in orbit. Human exploration of Pluto is not a fantasy. It's a Stage 7 objective, and it belongs on the list. Stage 8, the solar frontier, and the Kuiper Belt proper, the Oort cloud, the gravitational edge of our sun's influence. This is the far country. The timescales are long, the communication delays are brutal, and the technology requirements are substantial. We're talking about propulsion systems that don't yet exist at operational scale, about crewed vehicles designed for journeys of years or decades, about self-sufficient habitats that can't call home for help and expect a useful answer anytime soon. This is where the outbound philosophy stops being theoretical and becomes the most demanding engineering challenge our species has ever accepted, and I mean that as a compliment. Stage 9, extrasolar space, beyond the Sol system entirely. I'll be honest with you, this stage isn't for us. It's for our descendants, and it will require propulsion and life support concepts that we can lay the groundwork for, but probably cannot fully build in a single generation. That doesn't mean we don't start. The work of the first 8 stages builds directly toward this one: the technology development, the operational experience, the economic infrastructure, and it all points here. Extrasolar space is the reason the entire stack exists. Stage 10, extragalactic space, beyond the Milky Way. I include this not because any living person will see it, but because a vision that stops at the edge of our galaxy is a vision that has already set its ceiling too low. If you're going to conceive of a roadmap for the species, conceive of one worthy of the species. We don't get to extragalactic space in a century, probably not in a millennium. But we aim there anyway, because that's what it looks like to take the long view seriously. Now, here's what makes the outbound approach different from every government roadmap that came before it. Those roadmaps were built on the assumption of public funding, political will, and bureaucratic continuity, none of which are reliable over the timescales we're talking about. The Apollo program was a geopolitical sprint. It was spectacular. It also ended the moment the motivation that created it evaporated. That cannot be the model. The commercial model is different in kind. When SpaceX invests in a rocket, they need that rocket to make money. When a company builds a cislunar fuel depot, they need customers to fill it. When a mining operation goes to the asteroid belt, they need to bring something back worth selling. That self-interest, that fundamentally capitalist engine, is the thing that sustains programs across political cycles, across administrations, across decades. Government can set the table. Commerce has to be the one that keeps showing up to eat. Each stage of outbound supports the stages above it. LEO infrastructure serves cislunar operations. Cislunar logistics supports Mars transit. Mars surface operations inform the outer solar system push. Asteroid resources fund the solar frontier. The stack builds on itself, layer by layer, with expanding technology and expanding capability at each rung. That's systems engineering at species scale, and that's what it's going to take. We are right now standing at the base of this pyramid. Suborbital is operational, LEO is crewed, the cislunar tier is being actively planned and funded. The ramp is real. The question is not whether humanity goes outbound. That answer is already decided. The question is whether we go smart, whether we build the layers, whether we sustain the effort across the decades and generations it demands. not because a government told us to, but because the economics make it the right thing to do and the vision makes it the only thing worth doing. That's Outbound. Every stage in order, every stage in support of the next, every stage permanently occupied as the frontier moves farther out. The journey to the stars starts right here on the ground with the first stage. Let's get to work.